So here is our problem, and here we could see that if we put in standard form, that p of x will equal negative 2x, and q of x will equal 8, so x equals 0 is an ordinary point. So here will equal y is equal to the sum of n equals 0 to infinity, c n x to the power of n. So here we'll take the derivative as a summation of n equals 1 to infinity, and that will equal n times c sub n x to the power of n minus 1. And then here we'll take the derivative of that, the second derivative, which will equal summation of n equals 2 to infinity, and that would be n times parentheses n minus 1 c sub n times x n minus 2. So here we could sub everything in. So basically just plug the summations into that equation above. So that will be the summation of n equals 2 to infinity, n times n minus 1 c sub n x to the power of n minus 2 minus 2x and that will be the summation of n equals 1 to infinity n c sub n times x to n minus 1 plus 8, and that would be the summation of n equals 0 to infinity c sub n x to the power of n, which all equals 0. Now here we could just simplify it a little bit more. So we can't do too much to the first part of the equation, so that will be the same. But here we could distribute the x and put the x in that equation here. So that would be just 2 to the summation n equals 1 to infinity n c sub n x to just n. And we'll leave the last equation the same too. To add these summations together, the x's have to be the same power. So let's set k equals to n minus 2, and then the second summation n equals k and n equals k, because x to the power of n, they're both x to the power for the second one. So here, I forgot to write this down in the video I did, but n equals k plus 2. You could also see if we replace n with k plus 2, it will be k plus 2 times k plus 2 minus 1. So here we could just finish up and rewrite the equations with k. So it would be, so all the n's will be replaced with k plus 2 for the first summation, and then the second two will be exactly the same, except with n it'll be k. So now all the x to the power of k's are exactly the same. We have to get all the summations at the same starting point. So here we're just gonna add a few constants in front. So I think I make a few mistakes here, but I'll fix it later. But we have to take out a few sequences or whatever in front of it, so we could start at k equals 1 to match the middle one. So that was supposed to be 2C2. I'll fix it later, and it's supposed to be a plus. And here we'll take out a sequence for this one, which will be 8c sub 0 x to the power of 0. And then the sequence starting at, or the summation starting at k equals 1. And here I go back and fix my mistake. So I'll add a x to the power of 0 and a plus. So here I could rearrange it and just start merging it all together, sort of simplifying it. So now we could put it all into one summation and just combine everything. Right here, we distribute the 2 because that's still there, and we have to distribute the 8 here too, and that will all equal 0. So here I'm just going to copy and paste it, and here we could take out x to the power of k, and because they all have x to the power of k, so I will take that out, put it in parentheses or brackets, and that'll simplify it a little bit more. So right here, I'm just going to solve for C2 really quick because we put that in front. So yeah, rewrite the beginning part of the 2 that we took out. So C2 will equal negative 8C0 over 2. And that will simplify it to negative 4C sub 0. So let's now equate it, the stuff inside the summation, to 0. So I'll rewrite all of that. And here we can move the 2k ck plus 8, or minus 8 to the other side. So it'll be 2k c sub k minus 8 c sub k. But we could take out the c sub k. And now let's equate it to or solve for the largest subscript, which is ck sub k plus 2. So here I did have to blank out some stuff because I did solve it wrong the first time, but this part is still right. But let's start at k equals 1. So since we already solved for C2, we'll start at C3, and that will equal 2 times 1 minus 8 over 1 plus 2 times 1 plus 1, C1. And then we could simplify it to negative 6 over 3 times 2. And we'll just leave it like that for now. And that would be times C1. Now let's go to k equals 2. That was C4. And again, we'll plug in K into that equation we found. So right here, we know what C2 is, so we could plug that in. So we'll simplify that. So the C2 above on the screen right now is not what we actually solved for, but it's this one back earlier. And that's because I plugged in K equals 0 when we're supposed to start at K equals 1. But right here, I'm going to plug in 8 over 2 instead of negative 4C0, because I think it'll turn into a factorial. So you could just ignore the K equals 0, C sub 2 up top. Okay, so let's go to K equals 3. That'd be C5. And then we plug in all the numbers again. And right here, we know what C sub 3 is. So we'll go look at that, which is negative 6 over 3 times 2. And we get C times C sub 1. And that will equal 12 over 5 times 4 times 3 times 2, C sub 1. Moving on to K equals 4, that'd be C sub 6. Plug in the numbers again. So here this will equal 0 over whatever it is on the bottom. So it'll just equal 0. And it's also supposed to be multiplied by C sub 4 on the side. But that doesn't really matter because it will equal 0. So here we could do some simplifying again. Or plugging in what we know. So right here, we'll plug in C sub 6, but C sub 6 is 0, so it'll be what we have times 0, which will equal 0 again. K equals 7 will be normal, so just plug in some numbers. Plug in the values that we know, which would be 24 over 7 times 6 times 5 times 4 times 3 times 2, and that's C sub 1. And we could simplify that a little bit more. And I'll do one last one for K equals 8, C sub 10, and plug in the numbers. And then we could substitute C sub 8 in again, but that will also equal 0, so everything there will equal 0. So now we could use our original summation or power series. And here we could just expand it out all the way out to what we did. So I think we did up to 10. So I'll do that up to 10. So right here, we could start plugging in our values, or what we substituted into, so our C2, C3, C4s. So right now, I'm just going to go back and see that we have factorials on the bottom, so I'll just go simplify those. Again, the top one for C2, it's not the correct way to get it, I don't think. It's the way we did it before. But I'll go back and simplify or redo all the ones before. and this will just continue on for infinity. So in the lecture, I think they split it up into two parts, so I'll just do y sub 1 for c sub 0. So everything with a c sub 0 I'll take out. And it actually stops here because everything else is 0 that would have a c sub 0. So I'll highlight that. So this will not continue on, it'll just end right there. So we'll do y sub 2 next for everything with a c sub 1. And we'll plug in everything that has a c sub 1. Now this will actually continue on infinitely. Now I'll find the full thing just by combining them, adding the two together. And here I just went through with a calculator and started simplifying all of the terms. And right here, I'll find the derivative of all that. Now we did get y of 0 and y prime of 0, so I'm going to plug in y of 0 first, So I'm going to plug all of that in. And that will all equate to 9, because the zeros will cancel out, or not cancel, everything will turn to 0, so that will equal 9. So now plugging in y prime of 0, we already know, now that we know c sub 0 is 9, we can plug that in and plug in all the zeros and solve for c1. And here the 9 times 0 will cancel out, so c sub 1 equals 0. So now if we plug it back into what we had before, we know c sub 0 is, and we know c sub 1 is 0, so everything in the c sub 1 side will turn to 0. So we just need 9 times 1 minus 4x squared plus 4/3 x to the power 4. And since it is not infinite, that is our solution.